Hello everyone. So we are going to discuss the JEE paper, recent papers which have come right in the January sessions. So let us start from the starting, sessions which was on 21st, right? We'll discuss each questions and we'll see the level of difficulty which will help you actually to prepare for the next, April session. And also it will give you some clear cut ideas about making a certain concept stronger, right? There will be applications of those concepts and how to prepare such concepts and what kind of problems you should target, and what is the importance of NCRT in JEE preparation, right? A lot of things are there. So let us start with the first questions. Okay, so this paper which I am taking is JEE 2026 Jan sessions. Okay, so first I am taking 21st January 26 morning morning shift morning shift. Okay, so let us take the question. First question, the question says that there is a rod there is a rod, and this rod is being suspended by two threads or two strings, right? And they are saying that this mass is m and the length is l, right? Find tension in the left string just after right string is cut. So if you are going to cut this right string, what will be the tension here in this string? This tension we need to find out. That's the question, right? So let us see how to do that. Okay, so first of all, if I take this point, let us take this point. This point is A and this point is B, right? And this will be the center of mass of this rod. So here forces will be acting. So what are the forces that is going to act? We know the forces. So here the forces will be mg. This is cut means there is no tension here, right? So you can remove this part. Let us say now this part is removed, right? Okay, so I'm going to remove this part. Okay, right. So what will happen immediately that string is cut? So there is a tension. This tension we need to calculate. Mg is going to act. This tension is acting perpendicularly only, right? It is acting perpendicularly, and this is also acting perpendicularly. So net force is going to be in this direction only, right? And the center of mass is going to accelerate, right? So what will be the acceleration of center of mass? Let us write acceleration of center of mass. So acceleration of center of mass is net force divided by mass. Net force will be mg minus tension. Mg minus tension divided by mass. You got the acceleration of center of mass. Now, if I study rotation about center of mass, let us study rotational effect about center of mass, so we can calculate the angular acceleration. So if I calculate the angular acceleration alpha about center of mass, what will we get? Right? Torque, angular acceleration is torque about center of mass divided by I about center of mass, right? And what is this torque? Torque will be about this point. So mg is not going to create any torque, so torque is creating due to tension. And this distance is what? This distance is L by 2, because it is the center of mass. So tension into L by 2 divided by I center of mass, that we know ml square by 12. So from here you got alpha. So how much do we get? Tension, L got cancelled, this got cancelled, so 6 times it will come, right? 6 times, and this is mass and this is length, correct? Yes, you got alpha. Now we should know that this center of mass or this point is going to have a rotational motion. So rotational motion means I can calculate or I can write acceleration is equal to r alpha. R is L by 2 into alpha, center of mass. So now let us substitute that. Let us just do the substitution. So if I substitute that, a center of mass, we have got mg minus d by mass, and this is L by 2. Alpha center of mass is 6d by ml. So from here, what do we get? We get mm get cancelled, ll get cancelled, 2 into 3, right? So from here, we get 4t is equal to mg, and tension is equal to mg by 4, right? So that's the answer for this. So this question has got that option, tension is equal to mg by 4. Second option will be the correct answer. Fine. So then we will move to the next question. Let us go to the next question. Question number 2. There is a logic gate given. In question number 2, there is a logic gate given, and in this logic gate we have to find out what will be this expression, boolean expression for this, okay, or which gate it represent, okay, which gate it represent, okay. So let's take this is point A, this is point B. A and B are input, and we have to find that what is the equivalent gate for this. So let us write the boolean operation for this, okay. So A, after coming from here, it will become A bar, this also become B bar. After coming, what type of gate it is? Or, and not also is there, so nor gate. Nor gate means what? So this plus, and again you put a bar. This is the output. Now after this, what? Again opposite of this, so what it will become? A bar plus B bar, bar again one bar. This is what is C. This is what is C. Now let us represent this. So 2 bar will definitely cancel, so it will become A bar plus B bar. This is what is C. Now this can be written as A dot B bar is equal to C, right? This is De Morgan's principle or De Morgan theorem, right? Based on this we can write. So what does C represent? C is the output. What does this output represent? A dot B, dot means what? Dot means and a bar means it is NAND. So this is representing NAND gate, right? Clear? So let us move to the next. Question number 3. So there is an expression given P plus A by B T square plus half rho V square is equal to constant. They have given this, right? And they are asking P is the pressure, V is the speed, rho is the density. They are asking what is the dimension of A by B. A by B dimension they are asking. So we know that this is pressure. So this is being added with that. So when two terms are added, they must have same dimension. They must have similar dimensions. So this A by B into T square must have same dimension as pressure dimension, right? Now A by B dimension must have same as pressure dimension divided by T square dimension. Now pressure dimension we know. Let us write pressure. Pressure is force by area if you forgot. So pressure is force ml T minus 2. This is force by area means L square I have to divide. So it will become L power minus 1. This is what is pressure, and T square will come here. So we got this dimension as m L minus 1 T minus 4, right? This is the dimension of the term A by B, right? So we can go with option number 2, right? All these questions are memory based questions, so there might be some error in the options or in the question, okay? But we'll try to discuss as much as possible the important content of the questions, right? So let us go the next. Question number 4. Find the heat produced in the external circuit. So there is external circuit is given 1 ohm, 2 ohm, this is also 2 ohm, and this is 1 ohm, right? And this is 1 ohm, right? Like this. And they are asking this is 1 ohm and this is 9 volt. Okay, this point is point A, this point is point B. So they are asking heat produced in the external circuit AB. So in this external circuit, what is the heat produced? How will you calculate the heat produced, right? So to calculate the heat produced, if you can calculate what is the current here and this resistance, right? If you can calculate this resistance, then we can use I square R equivalent. So equivalent resistance we need, right? Correct. Equivalent resistance we need. Or if you need the voltage also we need. V square by R we can use. So anyway, so idea is that we need R equivalent for this. So how to calculate? Is there any symmetricity? There is some symmetricity because this is 1, 1, 2, 2. This is 1. So using Kirchhoff's law, we can attempt this question. Let us try that. Okay. So suppose if I take this current as I, right? So this current I is going, let us say that this is I1. So this remaining current will be I minus I1. And because of symmetricity, we can write this I minus I1 will go here, I minus I1. And this I1 must come here, right? Because there is symmetricity. So now what will be here junction rule when you apply from I1, you have transferred I minus I1. So remaining current will come here. What is the remaining current? I1 minus this. I1 minus this, when you do, what do you get? I1 minus this. So I1 minus I minus plus I1. So this will become what? 2I1 minus I. So this current and this current, when you add here, it should give I1. You can check that. So I minus I1 and 2I1 minus I. Here I get cancelled and 2I1 minus I1 gives I1. So current is now balanced. So we have done that, right? Now we have to calculate R equivalent of this, right? Or if you have calculated I1, then you will be able to solve power here I square R, I square R, I square R, I square R, I square R. All that you can do that, or you can calculate R equivalent, and then you can write I square into R equivalent. That is also okay. So how to calculate R equivalent? To calculate R equivalent, you should know the voltage across this point, right? And once you know the voltage across this point, so this R equivalent is voltage across AB, V by I. And voltage across AB can be written as EMF minus IR because this is terminal voltage. So EMF is 9 volt minus same current I is going here. So this is I into R means 1 divided by I. So basically, if you know I, you can calculate R equivalent. So I is, how do we calculate? So for this, we can think of making Kirchhoff's law application. So suppose if I go in this loop, what do we get? Apply KVL, right, in this loop. So from here to here, minus I1 into R. Correct? Minus I1 into R. Then in this loop again, minus current is 2I1 minus I into R. R is also 1 here, right? Then you are going against current plus. So I minus I1 into 2 is equal to 0, right? So here we are getting one equation. What is that equation? Try to find out. So minus I1 minus 2I1 minus 3I1 minus 3I1 minus 2I1, that become minus 5I1. Let us take 5I1 this side. So what is remaining here? I is remaining and 2I, so 3I is remaining, right? So we can convert I1 in terms of I, right? Now let us take this loop. Now if I take this loop, here what will be? Minus I minus I1 into 2, right? Then again in the direction of current, minus I1 into 1. Then coming through this again, minus I into 1. Then here minus 2 plus 9 is equal to 0. Now from here, let us write what do we get. So here we get minus 2i, minus 2i, minus 3i. That I will take that side, 3i, right? 3i. And this is plus 2i1, plus 2i1 minus i1, plus 2i1 minus i1 will become what? Plus i1. That you take that side, so minus i1 it become is equal to 9. Okay, now let us substitute i1 here. Substitute i1 from this equation. So from this equation, i1 is 3 by 5 of 5. Let us substitute it. So 3i minus 3 by 5 I is equal to 9. Correct. So from here 3 you take common, 3i I take common, then 1 minus 1 by 5, it will become 4 by 5. Correct, is equal to 9. So from here 3 into 3, so we got I as 15, 15 by 4. Correct, 15 by 4 ampere we got. And once we got this current, then what? Then here you can substitute to get resistance, right? Resistance we can calculate. What will be the resistance? 9 minus, or you can just do 9 by I minus 1. So 9 by I minus 1 will be how much? 9 by I, 9 by I minus 1. 9 by I, from here also you can think about it directly if you don't want so much calculation. So from here 9 by I will be what? 3 into 1 by 1 minus 1 by 5, 3 into 4 by 5. So this is 3 into 4 by 5, right? Minus 1. So how much do we get? R equivalent. Calculate R equivalent, right? So 4 into 3, 12. 12 minus 5. 12 minus 5, 7. 7 by 5. You got R equivalent. So now this calculation, once we are done with this, then you calculate power. Power you calculate. What will be the power? Calculation of power. Power is I square into R equivalent. So this calculation you have to do. This question involve calculation. So I we have already calculated, 15 by 4 square into R equivalent is 7 by 5. Check out this question. 15, try to cancel out 15 into 15 by 5. So 5 into 3 and 15 into 3, 45. 45 into 7, and here 4 square will give us 16, right? This calculation you have to do and check out what will be the answer of this. So 45 into 7, how much will come? 7 into 5, 35, 3, 7, 4, 28, 28 plus 3, 31 by 16, right? Let's check out this answer, how much this answer will come. Okay, let's say this is the power, this is in watt, but they are asking heat. So heat means what? Heat. We need power into time. So power we have calculated 315 by 16, and time they have given 1 minute. 1 minute means 60 second. 60 second. Now you calculate this. This is the answer. This question involves calculation. We have to calculate this. Okay. Try to check out. So 4, 4, 16, 4 into 15, right? Now you calculate this. We need to calculate out this. How much this will come approximately? Check out this. 315 into 15, 25, 2, 5, 7, 5 into 3, 15. This is 315, 5, 2, 5, 6, 7, 4725. 4725 divided by 4. Check it quickly. 4, 1, then again 4, 1, right? 4, 1, 32, 4, 8, 8 4, then 1, right, 10 4 2 4 5, correct. This is joule. That will be the answer. So this question involves some calculation. There may be other way also of solving that, right, but the processor will almost require that. By practice you can solve it faster. If you know star delta delta star method, those methods can also be employed for that. But still, even if you do not know, you will be able to solve this question, right? So let's move next. Only thing is that it may take some extra time. Let's go for next. Question number 5. Question number 5. Alpha particle having kinetic energy 7.7 million electron volt is approaching gold nucleus. Okay, so there is alpha particle, it is going and it is moving. Its kinetic energy they have given 7.7 million electron volt, and this is the gold foil. This is the nucleus of that gold foil, right? And let us say this is the nucleus. So nucleus charge is Z into E, you know that, and its charge is plus 2E, right? So it is going, and what is the distance of closest approach they are saying. So closest approach distance, you need to calculate this distance, closest approach. So closest approach means kinetic energy becomes zero and it's a head-on collision. So directly you can say that kinetic energy converts into electrostatics potential energy, right? So this kinetic energy converts into potential energy, which formula is K Q1 Q2 K Q1 Q2 by distance D. So from here, this distance will come K to E Z. Z is how much? Z is given 79 for gold into E divided by kinetic energy. Now this calculation you have to do, and kinetic energy is given as 7.7 million electron volt. Let us use proper units and do the calculation fast. So this becomes K is 9 into 10 to the power 9, right? 2 E 7 E divided by kinetic energy 7.7 million 10 to the power 6 electron volt means it is charge E. That's all. Now try to cancel out. E got cancelled, right? So what will be D? D we need to check. So take the powers. If you want, you can remove this, right? So if you remove this decimal, 10 to the power 5 will be there. So there is 9 into 2, 18 into 7. 9 into 2, 18 into 7, right? Divided by 7.7. Let us write this as 77. And let us write this as 10 to the power 5, right? And here, what is the power of 10 here? There is 9. There is 9. And this electronic charge also we have to write. So 1.6 into 10 to the power minus 19, right? So let us now try to solve this. This 7 will cancel out by 11 times. So we have got 18. This 1.6, let us write 16 and 11. Then here, what are the factors we will be having here? This will be 9, correct? So 9, and this will become minus 10, and here 10 to the power 6 will be there, correct? So 10 to the power minus 10, and here 10 to the power 6. So 10 to the power minus 16, right? We are getting this, right? Now we need to simplify it. So try to simplify and check how much do you get. In nanometer, we have to bring it. So if you have to bring it in nanometer, then 10 to the power minus 9, you take it separate, right? 10 to the power minus 9, you take it. Okay, so how much do you get? 10 to the power minus 9, if I take, you'll get 10 to the power minus 7, correct? 10 to the power minus 7. So 18 into 16 you do, divided by 11. How much that will come? 18 into 16, right? How much it is? 8 6 48 4 6 1 108, right? Table 288. 288 divided by 11. 11 you divide. 11 2 22, right? 68 11 6 66. 2.0, nearly it can come 26.2. So let us take it as 26.2, right? This whole divided by 11 into 10 to the power minus 7 will remain, correct? if you take out 9. So this is quite a small number that we are getting. It's a very, very small number in nanometers, right? Anyway, I think options are not given proper. So let it be, because this is memory based question. So maybe some options are not correct. Let us move next. Okay. Question number 6. An air-filled capacitor of capacitance is filled with dielectric. So there is a capacitor and dielectric is filled here. This dielectric is having a depth d by 3. This distance will be 2d by 3, right? Okay, and this value of k is given as 3. This is air, means k is 1, right? Okay, so equivalent capacitance, they are asking equivalent capacitance. So actual capacitance without anything is C. Now you have put this D by 3. What is C equivalent? So this will form and this will form two capacitances are going to be in series, right? So C equivalent will be C1, C2 by C1 plus C2. Let us apply that. So this is epsilon naught K times epsilon naught area by distance. Distance is d by 3 multiplied by this is epsilon naught area. Distance is 2d by 3, right? Then add them. So K times epsilon naught A by d by 3 plus epsilon naught A by 2d by 3. So what are the things that will come, which will get cancelled? So you see d by 3 factor, d by 3 factor, here this d by 3 factor will cancel out. And epsilon naught A, here one epsilon naught A got cancelled. So what is remaining now? In the numerator here k is remaining, epsilon naught A is remaining, 2d by 3 is remaining, 2d by 3 is remaining, divided by what else is remaining here? Here k is remaining plus how much? Half is remaining. Now substitute. This is C equivalent, and also note that epsilon naught A by D, that factor is C. So you can say that k, um, 3 3 by 2 will come here. 3 by 2 will come here. C divided by, yes, what will be that? Check out k plus half. K plus half means this will become 2k plus 1 divided by 2. 2 will get cancelled. So C equivalent is coming as 3k C divided by 2k plus 1. Now substitute this. K is 3, 3 into 3 9, 9c, 3 into 2 6 plus 1 7. So we got 9c by 7. That will be the answer, right? Let us move fast. Next question. Question number 7. Let us take question number 7. Find the moment of inertia of system formed using two. So this is a system. Okay, system of rod. Two rods are joined here, and we have to calculate about this point moment of inertia. Mass is m, length is l. This also mass is m, length is l. Okay, so we have to find the moment of inertia about this axis. These are two rods. So first of all, let us break them. This is first rod, this is second rod, right? So we need to calculate both the rods about this point. So about this point, what will be? And is this axis perpendicular? Yes, this axis is perpendicular, right? So about this axis, rotation of this entire system you have to take. So this is one rod. So about this axis, I1 plus I2 we have to write. So what is I1? I1 is about this rod, which is ml square by 3, right? First rod about the end point. Second rod, we have to apply parallel axis theorem to calculate I2. So what will be I2? I2 will be, we know about this, that is ml square by 12, and you have to translate to this axis. So ml square by 12 will be there, plus m into this distance, which is L square, right? So now let us add them. So basically we need to add all of them. So add all of them, right? So ml square by 3 plus ml square by 12 plus ml square, right? How much it will become? Calculate this. So from here you can take LCM as 12. 4 plus 1 plus 12, right, ml square. How much it comes out? 5. So 17 by 12 ml square, right? That will be the answer, 17 by 12, first option. Okay, let us move to the next question. Question number 8. Question number 8. Question number 8, if you see what they have given that there is electromagnetic wave. Electromagnetic wave. Electric field is represented by. Electric field is, I think just the value is given. Electric field. Electric field only value is given. So this electric field is given as 60 sine of 3 into 10 to the power 14 t. Okay, plus sine of 12 into 10 to the power 14 t. Right, this equation is given, and they are saying that at x is equal to 0, it is falling on a plate, and that plate has a work function phi. Phi is given as 2.8 electron volt. Okay, find the maximum kinetic energy. You have to calculate maximum kinetic energy of the emitted photoelectron. So this radiation when it is falling here, this radiation when it is falling, this is radiation or electromagnetic waves. So electrons will be emitted. This electron will have maximum kinetic energy given by E minus work function, right? So work function already you know, and answer should be in electron volts. So energy of this you have to calculate. E is the energy. Okay, this is electric field here, electric field. So how do we calculate energy of the photon? Energy of photon. Photon energy. So energy of photon, to calculate energy of photon, we need h into frequency. Frequency of the radiation we need. So which frequency we should use? You should note that this wave is a combination of two sinusoidal waves. Two waves is combining, or you can say it's a superposition. So which wave has higher frequency, that only we will use, because we want maximum kinetic energy. So which has higher frequency? This has higher frequency. This is omega given here. Omega you have to bring in terms of frequency. So you know that omega is equal to 2 pi into frequency. So frequency is omega by 2 pi, right? So we can use it here. So energy of the photon, energy will be h into omega by 2 pi, right? So h is how much? H we have to calculate. H we know, Planck's constant. So substitute this value, omega will be this substitute. H is 6.63 into 10 to the power minus 34, right? Multiply omega is 12 into 10 to the power 14 divided by 2 pi, right? Divided by 2 pi. So now check out how much it will come. This value we have to convert in electron volt, so we have to divide by, right, 1.6 into 10 to the power, divide 1.6 into 10 to the power minus 19. Find out how much this will be. Calculation we need to do. Check out the calculation. Energy of the photon. Approximate value we have to calculate. Yes. So nearly 1.6 can be cancelled out, nearly, not exactly, and the answers are slight difference. So we have to take care of this calculation. Okay. So nearly, if I take this is 4, then this will become 12, and this will become 6 by pi. 10 to the power, how much it will come? So here itself it has come minus 20, and this minus 19, that means minus 1 factor remained, right? So this is nearly 2.4 by pi, 2.4 by pi, right? So nearly 2.4 pi, if I take as 3.14, or let us take 3.2 nearly. So if I take this, I have easy calculation, 8 into 3, 8 into 4, 3 by 4 electron volt, correct? 3 by 4 electron volt it is coming. So you check out this calculation, how much will come. I think this is coming quite lesser. Quite lesser it is coming. But it should come more than 2.8 electron volt. I think the values given are not proper, right? So maybe because of this, it is based on memory base, so there may be problem with. But you have to calculate like this and substitute, and you will get the kinetic energy maximum, right? Let us move forward. Question number 9. Question number 9 we have to take. Find volume flow rate in the venturimeter given by. So there is a venturimeter given, venturimeter, and here like this narrow tube is there, right? And here also is there. So they are asking to calculate the volume flow rate. So here some area is there, cross section area. This cross section area is given as A, this cross section area is given as a small a, right? And they have given the ratio capital A by small a is equal to 2, and they have given 4a is equal to root 3. They have given this. Okay, and they have given pressure also. Pressure is given as 1000. Not pressure, this is density. Density, so water. So we know already this. So they have also said that this level difference in the level of water here and here, this is 5 centimeters. Okay. So how do we calculate, and what is the formula for venturimeter? Venturimeter formula for the velocity formula is root under 2gh divided by uh, a by a whole square minus 1. If you remember this formula, then we can solve it faster, right? This is the formula for this. Actually, the formula is based on the pressure difference between here and here, right? So here, where is pressure low or where is pressure high? So wherever area is small, their velocity is well, because the equation of continuity you will use. Suppose this is velocity v1 and this is velocity v2. So wherever area is more, a into v is constant, right? So here area is large, so speed is small, and speed is small, so pressure is more. Okay, so pressure should be more here, pressure should be less here. Pressure, I think this will go less and this will go up. Okay, pressure should be more here. Okay, so this level should be low here. Okay, anyway, so you have to use calculate this formula, you can use it. So let's see how much it is. Root under 2g is 10. If I take height is 5 centimeter, 5 by 100, and this is a by a ratio 2 square 4 minus 1. So this velocity is v1 that we are calculating here. Okay, v1 we are calculating. So this v1 will be how much? From here 1 by root 3, correct? Once you get v1, they are asking volume flow rate, so we can use discharge q is equal to a v1. A we got it here, root 3 by 4, root 3 by 4 into 1 by root 3. So this is 1 by 4, right? Discharge rate means meter cube per second. Everything is in SI unit, so that will be the answer. Let us move next. Question number 10. Question number 10. Ideal solenoid is kept with its axis vertical. So this is a solenoid and this axis is vertical like this. Okay, and they are saying that there is some current in this. Current is I naught. A charge q is thrown downward inside solenoid. Its acceleration of this particle is. So there is a charge particle which is thrown like this way. So what will be the acceleration? So you should know that the magnetic field will be existing in this direction parallel to the axis, right? Let us say magnetic field is upward, or you can take downward also. But this magnetic field and velocity is going to be parallel, right? This charged particle is thrown parallel or anti-parallel. So in that case, there is no magnetic force. Magnetic force is zero. right? Because velocity is parallel to the magnetic field, right? So only force is mg. Mg is the only force. So the only acceleration is going to be g. So acceleration will be equal to g, right? Let us move to the next question. Question number 11. Wave propagation, they have given electric field as a factor. So 69 sine omega t minus kx g cap. Find the direction of magnetic field. We have to find magnetic field direction, right? And so first of all, we should know that electric field is along the y-axis. Electric field is along y-axis, okay? And this is x-axis. Wave is traveling in positive x-axis. This is the direction of c factor, velocity, right? And we know that E cross B should come parallel to C vector. So definitely B vector must be along Z direction, right? E cross B should give C vector direction. So magnetic field is along this direction, along the direction. Which direction it is? It is K cap, right? So K cap, that will be the first option, right? Let us move to the next. Question number 12. Two rods of length. There are two rods are given, their lengths are 60 centimeters, 60 centimeter. Okay, each of them have same length L. Together into it they are joined. Coefficient of expansion, let us say this rod, first rod has alpha 1 and second rod alpha 2. They have given alpha 1, alpha 2. This is 24 into 10 to the power minus 6, right, per degree Celsius. And alpha 2 value is given as 1.2 into 10 to the power minus 5, okay, per degree Celsius. Okay, this alpha 1, alpha 2 given, their temperature are same and equal to, right now temperature is 30 degrees Celsius. What is, right, 30 degrees Celsius is there. Now you are heating it to 100 degrees Celsius. They are heating it. Find the final length. We have to find the final length. Final length means this length, let us say L. This length we have to calculate. So we can find out the equivalent alpha. So we should know that equivalent alpha for such combination is alpha 1 plus alpha 2 by 2. Very easily alpha you take and then calculate very fast. So alpha equivalent will be 1. Add them, divide by 2. Right? How do we add? This is 10 2.4 and 1.2, right? 3.6, 3.6 by 2, 1.8 into 10 to the power minus 5, right? We got alpha. Now you calculate. So the final length, let us say final length at temperature this is initial length 1 plus alpha delta t. Alpha is the alpha equivalent. So apply that. This L is the sum of this 60, 60, 120 centimeter. It will be all the calculations in centimeter. And then this is 1 plus alpha equivalent 1.8 to 10 to the power minus 5. And change of temperature is going to be 70, right? Just calculate out this one. We have to calculate this. So 120, 120, 1 plus, this will go away. So how much it will become? If you want, you can open it also. 120, you can open it. So this is 120 plus 120 into 1.8 into 10 to the power minus 5 into 70. So calculate this. Check out the answer. 120 plus. This will become 12, right? 12. 12 into 18, right, into 7 into 10 to the power minus 4 you can take. Now you do the calculation. 12 into 7, 84. 84 into 18, 84, 32, 3, 88, 64. 64 plus 3, 67. Then 84. 2, 1, 9 plus 6, 15. Right? Okay, and 10 power minus 4, 1, 2, 3, 4 will come. So 120.1512 centimeters. Clear? 1512, correct option third, right? So like this you have to do calculation little bit fast. Okay, then let us go next. Next is question number 13. Find charge, find change in internal energy of gas if its temperature changes. So change of temperature of a gas is given. So some gas is there, right? And its temperature change delta T is given as 10 Kelvin. We have to find change of internal energy. How much is change of internal energy? Number of moles of gas, number of moles is given as 10, and they have given Cp. Cp they have given as uh, specific heat constant pressure is 7. Units are in calorie per Kelvin mole. Okay, this is the units, and R value is also given as 2 calorie per Kelvin mole. How do we calculate this? Yes, delta U formula. What is change of internal energy can be used as CV delta T. Can we directly use this? CV, how to calculate? So you know Cp minus Cv is equal to R. So Cv is equal to Cp minus R. They have given this. So Cp they have given 7. 7 minus 2, that become 5. Right. So let us use that. Number of moles 10. This is 5. Change of temperature is 10. So that become 500, and the unit will be in calorie because they have given the units in calorie. Okay, correct. Let us move to the next question number 14. Two mechanical waves on the string equal to having linear densities. Two mechanical waves on a string. So suppose there are strings of length L, and this is another string same length. This is first string, this is second string. So some string waves is going in this, right? They are saying that this mass density ratio mu1 mu2, this mu1 by mu2 ratio they have given as 1 by 2, right? Find the ratio of time taken for a wave pulse to travel from one into other end. Time taken ratio. So time is equal to distance by speed. Distance by speed. Now speed is equal to what? Root under tension by mu. So what about the tension in this string? Is this same? Hmm? They are saying that they have same tension. So if tension is same, then time will be proportional to root of mu. So T1 by T2 ratio we have to calculate. That will come root under mu1 by mu2, and mu1 mu2 they have given. So the answer will be 1 by root 2, or 1 is to root 2. Correct. That's the answer. Let us move to the next. Question number 15. So there is a graph of potential energy graph versus x graph, potential energy versus x graph, and this graph has different lines like this, like this, like this, like this. Okay, so there are some points given like A, B, C, D, E. Now what they are asking here, they have given this as theta 1, this they have given as theta 2, this they have given as theta 3. They have also given tan theta 1 is equal to 1, tan theta 2 is equal to 3, tan theta 3 is equal to tan theta 3 is equal to minus half. They have given all these values, right? Okay, so now what we need to do is, they are saying that FAB be force acting on particle during A to B. During A to B, some force is acting, that is FAB. Similarly, force acting during this is force BC, force CD, force DE, like that. And they are asking you to arrange them in arrange magnitude of this force in decreasing order. So highest force first, magnitude. Okay, so how do we calculate force? We know this force is equal to minus du by dx, and if you take magnitude means just du by dx, magnitude of force. Okay, so du by dx, we have to take magnitude of this slope, right? Take the magnitude of this slope, du by dx. So here, what is the slope? Tan theta 1. So this force AB, this is force AB, right? What about force BC? Tan theta 2 slope. This is force BC. Magnitude of this you take. So force DE is given as half magnitude. What about force CD? Slope is 0 there. Now, which is the highest? Which is the highest? Highest is this is the highest. So force BC, let us arrange them. So force BC is highest. After 3, 1. So force AB. After half, force DE. After that, force CD. Right? This is the decreasing order. Right? Let us move to the next. Question number 16. So question number 16, if I take, what is there in that? Work done moving a charge. So this is x-axis, y-axis, and this point is origin 0 0 0. You can take if it is z-axis. So they are saying that there is a charge particle here. This charge particle is 10 to the power minus 6 coulomb, right? Sorry, 10 to the power minus 8 coulomb. And we have to move another charge from A to B, A to B, right? And A coordinate is given 5, comma 4, comma 2 root 2, and B coordinate is given as 2, comma 2, comma 1. Which charge we have to move? Let us say the charge Q1 we have to move. Q1 charge is how much? Q1 is 2 micro coulomb, and this Q1 is here, and we have to move it and bring to this. Okay, any path you bring, it doesn't matter. They are asking to calculate work done. So you know work done is equal to charge into potential difference. Here charge which you are moving is Q1, and you are going from A to B, so potential of B minus potential of B, potential difference. Now this potential is created due to this charge. This charge is acting like a source charge, so potential of A will be, right, this distance, let us write that as r1, and this distance let us write as r2. Okay, so potential is a scalar quantity, right? K q r1, and potential of B is k q by r2. What is r1? Let us see what is r1. So r1 is nothing but the magnitude of this root under, right, 5 square plus 4 square plus 2 root 2, 2 root 2 square, that means 8 it will be. So check out this 25, 25 plus 16, 25 plus 16, 41, 48. So 7 it will become, right? What will be r2? Root under 2 square plus 2 square plus 1. So 8 or 9, 3 it will become. Now let us substitute that. So Q1 is how much? If you want, first let us write that. VB is what? KQ by R2 minus KQ by R1. You can take KQ1 out, 1 by R2 minus 1 by R1. So let us substitute. K is 9 into 10 to the power 9. Q is how much? 10 to the power minus 8. Q1 is what? 2 microcoulomb, 2 into 10 power minus 6, right? We got this. And what about 1 by R2 minus 1 by R1? How much it will be? 1 by R2 minus 1 by 1 by 3 minus 1 by 7. How much it will be? 21 will be in the numerator, right? And 7 minus 3 will be 4. So solve it. Check out this. So 3, 3, 9, 3, 7, right? How much it is? 3 into 2, 6, 6 into 4, 24. 24 by 7 into 10 to the power, you check. 10 to the power, you check. This will become 1 and this will become minus 5. Correct? Right? So 24 by 7. Now we have get in answer in microjoule. So you try to bring in microjoule answer. Give the answer in microjoule. Right? So work done. Means 10 power minus 6 we have to keep. That means multiply with 10. So 240 by 7, you check. 7 into 3, 21. Right? So 37 into 4, nearly that. So 34.3 microjoule. Right? That will be the answer. Right? Let us move to the next question. So I think this next questions are not given. Maybe that is not present, but let us try next section, section B. Section B we will solve. Section B we will solve. Solve section B. Question number 21. Question is, satellite is revolving around planet in orbit. So there is a satellite. This satellite is revolving around a planet, and this radius of orbit is 1.5 r. R is the radius of this planet. Okay. Hmm. Additional minimum energy required to transfer the state to new orbit. So we want to change the orbit to 3r. That means we want to double the orbit. So what extra energy is required? Try to calculate that. So first of all, the energy required is nothing but energy required is nothing but energy difference, total energy. So total energy difference, change of total energy. What is total energy formula? Total energy. So total energy formula we should remember what it is. First of all, it is minus half G. What is the total energy formula? In case if you forget, then you need to think of kinetic energy, because the kinetic energy is exactly same in magnitude of total energy, but it is minus. Okay, but you should remember. So minus half G m by radius. Radius is how much? Radius. What is the radius? G m by radius. What is the radius? Radius of the orbit radius it is. Okay, this is the formula. So if I use this formula change, so I will take half G common and 1 by radius. So it is 1.5 r minus 1 by 3 r. Calculate this. Okay, so this will be half Gmm. So this is going to be 2 by 3, right? So that becomes 1 by 3 r. So finally you get Gmm by 6 r, right? So they are asking what is this factor. This factor they are asking, so this is 6, right? Fine, let us move to the next question. Question number 22. Question number 22. There are two springs of spring constant. Two springs are given. Spring constant is 20 plus minus 0.2. Another spring constant is 30 plus minus 0.3. Okay. They are asking the percentage error in is equivalent. So equivalent is what? K1 plus K2. So first of all, you calculate the error in this. So error will be calculated like this. So error is 0.2 plus 0.3, so that becomes 0.5. Once you get this error, then percentage error, delta K equivalent by K equivalent into 100. So this is 0.5, and sum of this 20 plus 30, 50 into 100. Correct? So how much that becomes? Yes, 1%. Correct? 1%. Fine, let us move to the next. Question number 23. 23 you take in YD setup, a slab of wood is inserted in front of one of the slit. The interference pattern shift is. So they are saying that this is YDSC setup, right? And you are introducing a slab of mu and thickness is T. Mu is the refractive index, T is the thickness of the slab. So they are saying that after you introduce, so the shift happens. So this is central bright fringe. Central bright fringe will shift, and then shift is given as uh, shift is what we have to calculate. Interference pattern shift. No, this is given as 0.2 centimeter. Shift is given. We have to calculate the thickness we have to calculate. Other values they have given. They have given refractive index is 1.5 they have given, and that's all. Okay, distance capital D, distance between this capital D, that is given as 50 centimeters, and small d slit distance is 1 millimeter. Okay, small d, these values are given. So what is the formula for shift? Shift formula we should know. Shift formula is mu minus 1 uh, t into capital D by small d. Correct? This is shift formula. Let us now substitute that and solve. Yes, we should remember shift formulas. If you remember shift formula, you can quickly solve it. Try to put it and solve it. And answer is given in micrometer. You have to bring. Okay. So 10 to the power minus 2, mu is 1.5. So this become half, 0.5. T we have to calculate. Capital D is how much? 50 centimeters. So 50 into 10 to the power minus 2. Small d, small d is 1 millimeter, 10 to the power minus 3. Okay, so calculate T from here. Calculate out. So this 10 to the power minus 2 will get cancelled. Here we got 10, this 10 got cancelled, right? Right, so t becomes how much? This become 25. So here 0.2 by 25 will come. 10 to the power minus 3 has already come here, right? So 0.2 by 25, 10 power minus 3 has already come. So this become 2 by 250. 250 into 10 to the power minus 3. So we have to bring in micro, means 10 to the power 1000 you multiply. 1000 you multiply. So 2 into 1000 by 250 into 10 to the power minus 6, right? So how much it will come? Check out. T will come how much? 8 micrometer, correct? 8 micrometer, that will be the answer. Then let us go to the next question. Question number 24. Question number 24. A particle of mass 1 kg initially resting at origin starts moving under influence. So there is a force acting on a particle, and this force is given in terms of vector. Okay, like this. This force vector is given. They are saying that the speed of the particle at, so originally the particle it has origin. Origin means 0, 0, 0, right? The particle is at 0, 0, 0 initially, and mass of the particle is 1 kg, and this force start acting. They are saying when time is 1 second, then what is the speed? What is the speed here? This is speed they have given as root alpha. We have to calculate alpha. So how to calculate? So force is mass into acceleration. Mass into acceleration. Mass is 1, so this is acceleration. Acceleration vector is 4t cube I cap minus 3t square j cap. Acceleration we can write as dv by dt. So dv vector become 4t cube dt minus 3t square dt. Okay, so when you integrate this, this is change of velocity. So initially it was at rest, so initial velocity was 0, initial 0. So this is final velocity only, right? And this integration will give t to the power 4 I cap minus this will become t cube j cap, and the limit you have taken from 0 to 1. So this is going to give us I cap minus j cap. So what is the magnitude of this velocity? Magnitude is speed, so root under 1 square plus 1 square. So that means this is root 2. So alpha is 2. Correct? Alpha is 2. Let us move to the last question. Question number 25. Focal length of objective and eyepiece are given. Compound microscope. What happen in compound microscope? This is small, this side is large. So this is objective and this is eyepiece, right? They are saying here that focal length of objective focal length they have given as 1.25 centimeter. Focal length of eyepiece focal length is given as 5 centimeters. Right, tube length. Now you should know what is tube length means. Tube length they have given. So first of all, if you draw this, no, and this is the focus of the objective, and here will be focus of eyepiece. So this distance between these two, that is called tube length L. Tube length L is given as 26 centimeters, right? So what are they asking here? Find the magnification of compound microscope in normal adjustment. Magnification, magnification in normal adjustment. Normal adjustment means what? Normal adjustment means the relaxed eye. Relaxed eye. Remember, relaxed eye means this image is formed at infinity. So for the image to be final image to be formed at infinity, the object for this, for this object, it should be formed where? It should be formed at focal. Its focus. Correct? This focus. Now, the object, actual object may be somewhere here, right? Actual object may be somewhere here. So now you need to think about it. Magnification formula. If you remember magnification, it's okay. MO into ME. This is the magnification formula. And if you take this case, so magnification of this is D by F. D by F. This magnification, how to calculate magnification of this objective, right? Magnification of objective. So this distance is the image distance and this distance is the object distance for objective. Okay, right? So how do we calculate this? Magnification, we have various formula for magnification. Magnification is minus V by U, or magnification is F by what? F by F minus U is equal to F minus V by F. Correct? These formulas, if I use this formula, the last formula, this formula, F minus V by F minus V is what? Huh? Or V minus F, we can also take. So this distance is what? This is magnitude is what? Because this is F naught, for objective we are calculating, this is V. So this you can take as F minus V or V minus F. V minus F basically it is, right? So this is V naught minus F naught. So we can take a minus sign before it, right? Because it is inverted images. So anyway, so here this distance, and this is what is L, right? This distance is L. So we should remember this formula, right? We should remember this formula. So if you remember this formula, we can calculate magnification directly. So let us calculate magnification. L they have given how much? 26, and F naught is given 1.25 into D is 25 centimeters, and FE is 5 into 5, right? And you can remove this, so 100 factor will come here. So from here 25 into 5, 25 into 4. So we are getting this magnification as 26 into this 5 will also will get cancelled. So we got 4 into 10, 104. That is the answer. Fine. So I hope you got the idea about this morning shift on 21st Jan. These questions which are coming, some of the questions are in lengthy in calculation, right? And some of the questions are direct, straightforward. Few questions are tricky, not more. So definitely this paper, you cannot say it is tough. It is easy to moderate side. This can be taken as easy to moderate side. Fine. So thank you for your attention. Then we will take up the next evening shift paper, right? Thank you all.